Okay, we're going to solve this 2 by 2 system using Gaussian elimination by getting into row echelon form. That sounds like fun. Okay, first we are going to write this in matrix form. So remember our goal here is A times some X vector, some variable vector, equals some constant vector. And we just write all of our coefficients in our matrix A. Our variables here in this variable vector, which is in this case a 2 by 1 matrix, and then these coefficients over here on the other side. And remember, like these literally say the same thing. Think about multiplying this 2 by 2 multiplied by, so this means multiply, that's my rank, 2 by 2 multiplying, maybe I'll use a dot here, this rows by columns, 2 by 1. In order to multiply matrices, the insides have to be the same, which they are. Then your answer will be from the outside. The answer will be a 2 by 1. That's what we have here, a 2 by 1. 2 rows, 1 column. Notice if I take this row times this column, I get 2x minus 3y equals -9. Yeah. 5x plus 4y equals 58. Okay, so we've written, all we've done so far is written this in matrix form. Now let's write our augmented matrix. So we just copy over that matrix A, and then we put this little dashed line in here to remind ourselves that we're augmenting, we're changing, we're adding on something to matrix A here, and that's this coefficient vector over here. Okay, now my goal for row echelon form is to turn this into what we call an upper triangular with ones along the main diagonal. So I want a 1, a 1, a 0, and some number here. And then I'll get 2 numbers here and here. This is my goal, to turn these into 1s and turn this into a 0. And then for fun, we'll take this a step further and get row reduced echelon form, where this is also a 0. Okay, so we need to get some 1s, we need to get some 0s. We work 1 column at a time. So I start with column 1. Get your 1s by dividing. So the first thing I want is a 1 right here in that location where that 2 is. Ooh, I want a 1 right there. You get your 1s by dividing. So I'm going to divide. I'm going to take row 1, divide him by 2, and then that's going to become my new row 1. And this is the way we're going to do a lot with row operations. This is how we write out row operations, and it's a little confusing when you first see it. This means my old row 1. This will be my new row 1. So I'm replacing row 1. Remember, this is just an equation here. This is like taking this equation and just dividing everybody by 2. That's literally all I'm doing to try to just get x. That's really all we're doing. So what do we get? Row 1 divided by 2 will be 1, -3/2, -9/2. We're going to have some fractions here. We're just going to deal with it. So now my matrix will be, leave row 2 alone for now. Let's see, 5, 4, 58. Okay, step 1 done. We got a 1. So I got That was my goal. Got a 1. Ooh, right there. Use that 1 to get the zeros. So in each column, you get the 1 along the main diagonal, and then use that 1 to get the zeros. How do we get the zeros? By adding equations together. See, I need this to be a 0. Dividing through by anything, multiplying by through anything ain't going to turn to 5. I mean, I can multiply the whole thing by 0, but then what does that do? I get a whole bunch of zeros. That's not an equivalent equation to this. Remember, you're allowed to add equations together. So what I'm going to be doing is adding some multiple. So I want a multiple of row 1 added to the old row 2 to get a new row 2. Technically, what I'm generating here is some third independent equation. I'm actually creating a brand new equation out of the other 2. Okay, so what number would I have to multiply 1 by to cancel out a 5? A negative 5. So negative 5 times the old row 1 plus the current row 2 will give me some new row 2. We're not going to change row 1. This is where a lot of times students have issues. I'm very happy that I got that 1 there. That was part of my goal. I don't want to mess that up. I'm going to leave that 1 there. I'm using a copy of row 1 to fix row 2, but I'm going to leave row 1 alone. So I'm going to make a note here. Leave row 1 alone. We're just getting a new row 2. Okay, so let's write down what negative 5 times row 1 would be. And I'm telling you, the more of this math you write out, the happier you're going to be. Negative 5 times negative 3 halves will be positive 15 halves. Negative 5 times negative 9 halves will be 45 halves. We're going to have a lot of fractions here. We're just going to deal with it. The old row 2 is positive 5 for 58. Add straight down. I get a 0. That's what I wanted. Okay, now remember your calculator can add fractions for you. Say I don't want to go through this trouble right here. I want 15 halves. So 15 divided by 2 plus 4. I definitely don't want to be dealing with decimals. Decimals are not your friends here. Let's turn this into a fraction. I can go math into fraction and hit enter, and it'll turn 15 halves plus 8 more halves into 23 halves. Your calculator will do the fractions for you. And I forgot what I just had. 23 halves. Same thing here. If I don't feel like doing that, I could look at that and go, oh, well, that's 106 over 2. So that would be, I think, 151 over 2. But let's check it. 45 over 2 plus 58. Take that answer, hit second math, or no second, just math into fraction, hit that twice, 161. See, I done goofed. I'm glad I checked it. Oh, because twice 58 is 116. That's where I goofed. Okay, so that's my new row 2. So now let's rewrite our matrix. Row 1 stays the same. I used that 1 there to kill that 5, but I don't want to get rid of that 1. So that 9 halves, negative 9 halves, 0, 23 over 2, 161 over 2. Okay, we actually could now solve the system. We call this upper triangular form. So what we have right here is upper triangular. And we've done all the math we have to do to solve the system. This right here, if I were to write this out, says x minus 3 halves y equals negative 9 halves, and 0x plus 23 over 2y equals 161 over 2. So if we were actually solving this in the real world, we don't have to do all the other stuff I'm going to do here. Just solve this for y. Just divide both sides by 23 over 2 or multiply by the reciprocal. That's 161 divided by 23. I'm going to get y equals 7. Plug that in here. Once I get y, back substitute, solve for x. We're done. We're going to get x equals 6. We could solve the system here, and that's our ultimate goal, is to solve the system. But we're going to keep going here. We're going to turn this into a 1. So my next step says next, get a 1 right there. Because my goal, remember, was to get 1, 1, 0, and some number equals some number, some number. This is row echelon form, where we have ones along the main diagonal, zeros all below those ones. Wait till we do a 3 by 3, and we'll see a more complicated version. Okay, so how am I going to get a 1 there? We get our 1s by dividing. Get your zeros by adding copies of the 1. Get your 1s by dividing. So I'm going to divide row 2 by this fraction. How do you divide by a fraction? Multiplying by the reciprocal. So I'm going to take row 2 and multiply him by 2 over 23. All the way through. So what are we going to get? We're going to get 0, 1, and then here, maybe I'll write this here. 161 over 2 times 2 over, it's 23, is 7. 23 goes in there 7 times. Okay, so now what's my matrix now? It's 0, negative 3 halves, negative 9 halves. Oh, sorry, it's not 0. It's 1, negative 3 halves, negative 9 halves, 0, 1, 7. All right, let me make sure that's right. Okay, we are now in, this is row echelon form. That means we have ones along the main diagonal, zeros below this triangle here. This equation says x minus 3 halves y equals negative 9 halves, and 0x plus y equals 7. Now it's just back substituting. So if y equals 7, we get x minus 21 over 2. Just plugging in y equals 7 equals negative 9 halves. Add that over, x will be, let's see, 21 minus 9 will be 12 over 2, which is 6. So my solution is the 0.67. And we're done. That's the solution. But I'm going to take this one step further. So for fun, let's go a step further and do row reduced echelon form. That's going to look like this, where we have the identity matrix here, 1, 1, 0, 0, and then we have some numbers over here. So ones along the main diagonal, zeros everywhere else. Row echelon form doesn't require having a 0 here. Row reduced echelon form does. If I get a 0 there, then everything is done, my answer will just be sitting here. So how am I going to get a 0 there? So still need that 0. I don't have that. We get our zeros by adding copies of our ones. We use our ones to get our zeros. So I need 3/2 times row 2 here to cancel out that negative 3/2. Plus the old row 1, and this will become the new row 1. So 3/2 times row 2 will be just multiplying everybody by 3/2. You get 0, 3/2, 21/2. The old row 1, 1 negative 3/2, negative 9/2. See, it's important that I had this 0 here. This is why you got to work one column at a time. If I did not have this 0 here right now, playing this game, trying to make that 0, I would be messing up this 1. I don't want to, once you get your 1s, you don't want to mess them up. So you always get a 1 in a column, use that 1 to get your 0s above and below it, get a 1 in the next column, use that 1 to get your 0s. Okay, adding straight down. I get 1, 0, 21 minus 9, we get 12. Oh, we get 6. This is my new row 1. That was old row 1. This is new row 1. That's 1, 0, 6. Row 2, we didn't change. He looked like that. Look at that. There's my answer. There's my X. There's my Y. We're done. Now, did we have to go through all this math? No. Once we got to upper triangular, we could have just done a bunch of back substitution. Like, really, we're doing all this math we would be doing here. We are still doing it from this step. We're just doing it in a way that's more natural to us. Like divide through, get y equals 7, plug that in, get x equals 6. That's really all we're doing. This process, though, just takes care of all that for you. And this can be put into a computer. You can tell a computer to always do these steps. Your calculator will do all of this for you. You type in this augmented matrix into your calculator, it'll spit out row reduced echelon form with your answers right there. Okay, and that's a good place to stop.